In this video, we're going to be writing a linear cost, revenue, and profit function for a real-life problem. So at a summer art show, a vendor sells lemonade for $2 per cup. The cost to rent the booth is $120. Furthermore, the vendor knows that the lemons, sugar, and cups collectively cost 50 cents for each cup of lemonade that's provided. We're going to begin by writing a linear cost function to produce X cups of lemonade. So what do we know about our cost? Our cost for the cups of lemonade. So again, X represents the cups of lemonade, so cups of lemonade. Well, we know that it costs 50 cents for each cup of lemonade provided, right? 50 cents for each cup of lemonade provided. So we've got 50 cents for each cup of lemonade provided. But remember that it costs this gentleman, or this vendor rather, $120 to even rent the booth. So there's an additional cost of the $120 to rent the booth. So this is our linear cost function. So we take the fixed cost of the booth and we add it to the varied cost of the cups of lemonade for each cup, the cost for each cup. Now we're going to write a linear revenue function for selling X cups of lemonade. So we're looking for a revenue function. And again, X is still our cups of lemonade, so we're still talking about the same thing here. Remember that we're told that he sells, or the vendor sells the lemonade for $2 a cup. So we're looking at $2 for every cup of lemonade sold. That's going to be the money that the vendor brings in, $2 per cup. Now we're going to write a linear profit function for producing and selling X cups of lemonade. Notice still that X is representing our cups of lemonade. So we're going to find our profit function for that cups of lemonade. Now profit is basically taking your revenue and subtracting your cost from it. So we're going to be taking our revenue equation and subtracting our cost equation from that. So we're going to plug in our revenue equation, 2.00x, and we're going to subtract our cost equation, which was 0.50x plus 120. But remember, we're subtracting all of that. So that means that we need to distribute that minus sign. So now I'm just going to go ahead and convert this to a 2x just to make it a little bit easier. So we have 2x minus 0.5x minus 120. From here, we're going to combine our like terms. So if I have 2x and I subtract 0.5x, so if I have $2 and I subtract 50 cents, that means that I have $1.50 for each of my cups of lemonade, minus the $120 for my booth. So my profit equation then becomes that I only make $1.50 for each cup of lemonade that's profit, minus $120 for the booth. So that is our profit equation. We can now ask ourselves, well, exactly how much profit will you make if you sell 50 cups of lemonade? So you produce and sell 50 cups, which means that we're going to be plugging in the number 50 in for our X in our profit equation. We're using our P of X because it asks for profit. So we're going to have $1.50 times the 50 cups of lemonade that are being produced and sold. And we're going to plug that in. And we're going to find that the profit for 50 cups of lemonade is going to be negative 45. So what that means is that we are going to lose, let's try that again. We're going to lose $45 Because we haven't sold enough to cover the cost of that booth yet. So that's our cost there. You can write it either way. So how much profit will be made if you sell 128 cups? Well, let's go ahead and let's plug in 128 into our equation, and let's see what we get after we produce and sell 128 cups of lemonade. And if we plug that into our calculator, we're going to see that we have a positive 72. So the vendor will make $72. So they've covered the costs and have a profit of $72. We call that being in the black. Up here where we lost $45, we call that being in the red or being in the negative. So what is the break-even point? Well, what does break-even mean? Well, break-even means basically when will your costs and your revenue equal each other? So again, when will your costs and your revenue equal each other? Or in other words, when will you have zero profit? So you won't be in the black or in the red. So you won't have lost any money, but you also will not have made any money. So we're going to go ahead and we're going to take this P of X equals 0. So we're going to take our 0. Let's give ourselves a little bit more room here. 0 equals $1.50 times a cup of lemonade minus 120. And here we're now going to solve for X. So we're going to add 120 to both sides. And then from here, we're going to go ahead and we're going to divide both sides by the 150. And we're going to see that that's going to give us a value of 80. So if the vendor produces and sells 80 cups of lemonade, the cost and revenue will be equal, which will result in a profit of $0. This is the break-even point. So those 80 cups is our break-even point. And that is how to write a linear cost, a linear revenue, and a linear profit function for a real-life problem.